Hello, everyone. So yes, indeed, today we're going to talk about test-driven development, but with Vue.js. That's the twist. So my name is Sarah Dayan. I work at Algolia. So if you don't know Algolia, you probably already used it. If you went on the Vue.js documentation, it's powered by Algolia, like many documentations out there. And I really love Vue. I love Vue. I've done lots of projects with Vue. I also love open source. I really enjoy open source. I enjoy this trust relationship that is created through open source. Like, I do open source and people use it in their project and they trust me with it. And they do open source and I use it in my projects. And that's really something that's awesome to me. And this is why I believe that testing is one of the pillars of writing robust software. It's not really an issue if your code is dirty, if it's not performant, if it's not dry, if it's not solid. It's less of an issue to me than if you don't have tests. Because you can always refactor dirty code, right? But refactoring becomes a lot harder when you don't have tests. Tests should give you confidence that you are not shipping broken software. That's about it. Tests are really practical. It is not about making your tech lead happy. Nobody is going to be mad at you because you did not write one extra test, and you don't get bonus point for that. The goal for a test is to be a lifeline for you. The idea is for you to be confident that when you push something new to the code base, you're not breaking things up. So, the problem is that testing can be tough, right? Especially with UI components. It's not that straightforward. And so as a result, we often neglect testing UI components. I don't know about you, but when I'm finished writing something like that, I look at it and I'm like, I have no idea where to even start. What should I even begin with to test that thing? Should I test the HTML structure? Should I call methods directly, one by one? Am I going for 100% coverage? And if I am I not tiptoeing between unit testing, integration testing, end-to-end testing? That's complicated, right? So what often happens? We do it later, we procrastinate, and we ship our code, our finished code, to production without tests. Or we write the tests after the implementation, and what can happen oftentimes is that we write tests that are not really finished, like they are not exhaustive. Or we go super defensive and we're like, yeah, I'm going to test line by line, everything. And so we create tests that usually really focus on implementation details, and so they're brittle. We will have to rewrite them every time. And the problem with those kinds of approaches is that with time, we test less and less, or with a lot less precision. And in the worst cases, we do it never. So by show of hands, who ever pushed code to production without tests? Nice, you're honest. So it doesn't matter anyway, because either you do that or you do too few tests or too many tests. The problem is that you're never really confident about hitting that deploy button, right? And so I don't know about you, but I don't really enjoy spending my nights and weekends fixing issues that could have been prevented by tests. So what can we do about it? Is there anything that we can do? Introducing test-driven development. So that's not a new technique. That's something that was popularized in the 90s by Ken Beck. So he's the co-author of the Agile Manifesto. He created extreme programming. And so the point of TDD is that you want to write the tests before you write the associated code. And the idea is that it forces you to think before you code. And this usually leads to much more robust code that behaves as expected. And if you heard about TDD but you've never done it, you may be thinking, oh, that complicated thing that I should be doing. It's actually not that complicated. It goes in 3 phases. The first phase is called read. So here the idea is that you write a test that describes an expected behavior, then you run it, and you ensure that it fails. So here, you're really writing the behavior that you expect, and then you're making sure that you look at your test and you want to see it fail. You want to see why it fails so you can fix it. And then it leads you to the green step. And the green step is about writing the dumbest, most straightforward code that you can make, to make the test pass. And the idea is that you want the test to pass as quick as possible. So it's okay that the test uses, that the code uses a stub, that you're returning the actual value directly. It's not about writing something that is right. It's about ensuring the outcome, focusing on the outcome. And finally, when your test passes, you want to go to the third phase, which is the refactor. So the refactor is about making the code right. It's about looking at performance, better data structures, etc. But the goal, the ultimate goal, is that your test should stay green. It should not go back to red. All right, but what does it have to do with Vue, right? Well, I believe that TDD and Vue are a really great fit. Because testing a component can be quite counterintuitive. It requires quite of a mental shift compared to a plain function or module, where usually you pass something in, you expect something out, end of the day. But here, it's really harder to know what to test and what should be the line between all those different kinds of tests. And with TDD, the really great thing is that you're not really trying to guess what to test from finished code. What you do is really, you start from what the component should do without trying to think about how it does it. And this ensures that all you test is the public API, but without forgetting anything. All right, so we're going to do it together. We'll see together what TDD looks like with Vue. I'm going to use two well-known tools. I'm going to use Jest as my test runner, and Vue Test Utils, which is the official Vue testing library. So we are going to build this beautiful star rating component. So our designer just shipped this beautiful mock-up, and so what we can see from here is that we have 5 stars, of which 2 are active. And we have a summary, a text summary just below. So, okay, no problem. Let's code that together using TDD. Thinking time, yes, we want to think before we code. We want to see, we want to think about what we're going to code, and then we want to implement it with TDD. So the first thing that we can see is that, yes, we have 5 stars to display. And this is our actual test case. Yes, this might be flexible later. We may want to go to 2 stars or 7 stars, but that's not really something that we want to think about just yet. Here, what we want to look at is I'm testing a specific case, and I ensure that my test is deterministic, that it always yields the same results. All right, so coding time, that's the scary part for me. Welcome to my editor. Can everyone see properly? Or should I go one zoom level in? Cool, awesome. So here, what you can see is that I have 2 files. I have my component, so it's empty. We have an empty file just with the template and the script, but it doesn't do anything. And here, we have a spec. So that spec is really just the boilerplate to start writing tests. So I'm getting some utilities from Vue Test Utils. I'm getting my component. I'm mounting my component before each test. And I am destroying it after each test. All right, so we are going to write our very first test together. And then we are going to do the TDD process. So the first thing that I can do here is to test those 5 stars. So I can say it renders the stars. Pass a callback. And so here I will go const stars, and I'm going to fetch those stars that I expect from my component. So I can say, OK, wrapper find all stars. So here I'm starting to define my public API with the star class. So I'm getting all the stars, and I can say I expect stars.length to be 5. Okay, seems like a pretty good test to me. And so here I can start my test with a watcher, so it keeps on running, and this should fail. So let's run jest. And so here, the idea is that because there is nothing in the file, it should fail. And it's actually going to tell me what I should be doing. So it's taking a little bit of time. And so here, awesome, you can see that my test is failing. So I'm personally happy about that. It's awesome because we passed the red step with flying colors. So here, instead of going directly into the green step, what I want to do is really look at my terminal, because the really great thing about TDD is that you want to take the feedback from your test runner as a feedback loop. This is a feedback loop that is telling you what to do. And the green step here, the idea is not to try and be smart. The idea is to follow what the terminal tells you. So this way you can write the minimal code to make things pass. So here what it says is that, okay, I expected 5, I received 0. Yes, sure, makes sense. So what would be the simplest, most dumbest way to make this pass? Well, the simplest is to just hard code 5 elements with the class star. So let's do it. So I'm going to create an unordered list, so ul li star. Okay, so I have 5 stars. I'm going to save, and this should be passing. And it's passing. So the green step is a success. So now I can move on to the refactor, because obviously this is not right. I don't always want to have 5 stars. Maybe I want to have 7, maybe I want to have 2, maybe I want to have 1,000. So what I can do, because I want this to be flexible, is to say, okay, if I want this to be flexible for the end user, I might pass the number as a prop. So no problem, we're going to pass the number as a prop. So we go here. So when we shall mount our component here with Vue test utils, we can say, I want to pass you some props. So you do props data, and let's call that prop max stars. Max stars is 5. Here in my script, I'm going to receive those props. So export default. And I'm going to pass some props, and I'm going to say max stars. Max stars is a number. And I'm going to use this. And instead of having those hard-coded list items, I'm going to remove them. And I'm simply going for a v4. I'm going to iterate on my max stars. And I'm going to say 4 star in max stars. And here, the goal is for my test to keep on passing. And my test still passes. So that's awesome. I just finished the first TDD cycle. I refactored. I can even refactor further. I can say, OK, I'm going to add a key, stuff like that. But the idea is that our test is still passing. So that's awesome. And we can move on to the next test. So if you remember, here we have 2 stars that are active. So those 2 active stars, we want to represent them the same way. So same idea. This test case is 2 stars. Maybe it's going to be flexible, different, but we don't want to really care about that for now. So here I can go and write another test. And this test is going to be quite similar. It expects the, it doesn't expect, it renders the active stars. And this way we can go a bit faster because we're getting good at this. And we can say, OK, const active equals wrapper, find all, star active. And we can say it expects the active length to be 2. Awesome. My test is going to fail. My test is failing, expected 2, received 0, no problem. Green step, I'm going to give you 2 active stars. You want 2 active stars? I'm going to make you happy. So the best and simplest way to do it is say, OK, I'm going to add a conditional class. So I can do class, I pass it an object, and I say active. And so the simplest way to say, if you want to, is I want to add the class active when star, the index which is 1 based here because we're iterating on a number and not on an array, star is inferior or equal to 2. and my test is passing. Perfect. I can refactor, and I'm going to refactor to, the idea would be to say, okay, I can pass an initial grade. I can say that by default, my component has an initial grade of X, which you get back from your database, wherever you want to go. So I can say, okay, I'm going to pass an initial grade. So again, I'm also defining my API here because I'm creating those props. And here I can say initial grade. Same thing is of type number. And here, I can simply change this into initial grade, and it should still be passing. Great. So we can finish our component with TDD with a third test. So remember this, this little summary at the bottom? Yes, we can implement that with TDD. So we go, it renders a summary, and this is going to be a different kind of test. So here it's going to say, okay, const summary equals wrapper.find. And so this time it's find, it's not find all, because we want to find one element, and we don't want to get an array of wrappers back. We want to get just one wrapper. So we say summary. And here we want to say expect summary.text to be 2 of 5. And so it's going to be interesting. So here Jess tells us, find did not return summary, cannot call text on empty wrapper. And it makes a lot of sense because there is no summary in our code. So Vue test utils, they don't find it, so they cannot call text on it. So same thing, we want to make our test happy. So we go, okay, you want a summary, I give you a summary. So the idea is always to write the simplest piece of code that you can. Summary. Awesome, so it still fails, but here the message has changed. The message says, expected 2 of 5, got nothing. Okay, so we can say 2 of 5, that's what you want. I'm giving you exactly what you want. Awesome, it passes, and now it's super easy to refactor into something that actually works. So it would be initial grade of max stars. And my test is still passing. And so it should be still passing. And so what you can see is that, yeah, then if later you want to say, okay, my component is clickable, this is something that you could super easily iterate on. There would be really no issue to iterate on that code. Right? So you might be thinking right now, what exactly are we testing? Because as you saw, there was no line of logic in our code that wasn't tested. But not everything was tested. For example, our HTML was not tested. The fact that I'm using an ordered list was not tested. And so at this point, you may be thinking, isn't TDD all about 100% test coverage? And so if yes, isn't it making our test a bit brittle? And if no, how do you know exactly what you test and what you don't test? Tests should give you confidence that you are not shipping broken software. Tests are not here to bash you on the head with rigid rules. The idea of tests is to give you confidence that you can add more code to your existing code base. So they're a friend. They're not a dictator. It's like everything. Extremes and dogmas are dangerous. And here, you really want to make sure that you're not breaking the contract that you've established with your end users. That's what you want to check. Nothing less and nothing more. And one great way to do it is to do black box testing. So if you're not familiar with black box testing, the idea is that you only want to assert the public interface. But what is the public interface when it comes to a UI component? Usually, and especially if you read the description on Vue test utils, which is a good one, it's like, usually it's the props that you pass, and then it's the interactions, the clicks, the hovers, the scrolls, right? That's about it. Not exactly. Because who are those users that we are talking about? To me, there are different kinds of users. First, you have the final user, and that user is the one who goes on a website that uses your component. So they click, they hover, they do all that stuff. But you also have another type of user, which is the developer. And the developer is importing your component in their code base. They're upgrading it, they're downgrading it, they're passing props, but they might also be styling. They might be someone on your team of 5 people where communication is easy, or your team of 100 developers where it starts to be much more complicated. And so you can start to see that with UI components, your public interface is usually much bigger than you think, whether you like it or not. When you're exposing HTML, that's not necessarily a choice, but you're doing it anyway. So it becomes your public interface. And so the single question that you usually can ask yourself when you're like, okay, should I test this or not, is the following. Do I care about this if it changes? Does anyone care about it if it changes? If the answer is yes, you test it. If the answer is no, no need for a test. And so what about those edge cases that we were talking about, this HTML, for example, because that UL, that LI, maybe a designer is relying on those, they're targeting those, but maybe I'm like, when I'm designing it, I'm like, yeah, but I don't want this to be in my public API. That's not something that I consider part of my public API. So I want to be able to change it without bumping up a major if I want to. What do you do in those cases? You document all the things. You absolutely need to document the things that people might be relying on, but they should not rely on. So that's the first rule. Please document it. Make it big, bold red in your documentation. And also provide something for them to fall back on. If people should not be using HTML, they should not be relying on it, provide classes everywhere. And those classes would be part of your public API. All right, so what did we learn? The first thing is that TDD lets you write robust tests, not too many and not too few. And adopting TDD for UI components helps you focus on exactly what to test by defining before you write the code if this is part of the contract or not. The second thing is that TDD encourages refactors, which leads to much better software design. When you're writing tests after coding, you're usually not really in a refactor mindset. You're done. You're finished with the implementation. And to me, this creates quite of a problematic separation between your tests and your code. And with TDD, you're creating a much deeper connection between code and tests. And the way you do that is by creating a strong focus on making the API reliable. And that's possible because the implementation comes right after you've guaranteed the outcome. One of the things I love with TDD is that it really forces you to focus on the right things. And your software's contract is infinitely more important than the way you implement it. If there is one thing that you need to remember from this presentation, it's this one. If there is one thing to tweet, it's this one. Your software's contract is infinitely more important than the way you implement it. Your implementation will change. It's not an if, it's a when. The language will change. You will get better. Things will change in general. And that's okay. It's okay to change the implementation. It's not that important. But a strong contract is extremely important. And this is actually why that green step, that looks a bit silly because we're testing the obvious, this is why it's so important. Because instead of implementing your way to a working solution, you're inverting the relationship. You're working backwards. And this way, you focus on the contract first, allowing your implementation to remain disposable. And since it comes last, the implementation, you already established the contract. It's already done. So now you have the mental space to make things right, to refactor, to focus on performance. And you can do it because you've already taken care of the contract. You have your constraints, and now you can work and express your creativity in the boundaries of those constraints, those same constraints that you've established for yourself. The third thing is, obviously, TDD is much easier to follow with specs. So we did not have specs. We had a mock-up. This is not specs. This is not ideal, but this is already something. Ideally, you want to go with specs. And the great thing with TDD is that it inspired a lot of frameworks. For example, there is one called ATDD, Acceptance Test Driven Development, which is something that you can do with your business parties, your PMs, your project managers. And so you will write together some specs that you can turn into tests and then that you can implement. But obviously, you may have thought about it. TDD takes a lot of time. And especially if you're used to working in a rush, you might be thinking, there is no way I can do TDD. I have to go fast. I have to go fast. There is no way that I can take that kind of time to develop. So, is it worth it? Like, after all, we're all developers. We're all working on projects that work. And even if you're not doing TDD, it works. So why should you change? Why should you change the way that you're working? Why should you trust me? You don't know me. You don't have to trust me. Well, let me try to convince you with a few points. The first one is that with practice, you will get faster at TDD. So it's the same as everything. Like, you might be quick. Like, I'm sure that when you started typing on a computer, you were like, and now you're like it goes super fast. It's going to be exactly the same. So don't discard it because it looks slow or because when you tried, it was slow. If you really want to give it a shot, if you really want to try it, you can get really fast at it. And the second, and I would say the most important one, is that fixing bugs is far more costly than preventing them. Who ever had to fix a critical production bug? All right. Do you remember those feelings, the sweat, like the feeling that you're basically holding the wound of a surgical patient with one hand and you're operating with the other hand, but it's like at night, it's in the desert, and you have a Swiss Army knife, right? It's stressful, it's suboptimal, you're probably going to mess up something else around it, and like, this is not something that you want to do. This is not what software development is supposed to be about. You're supposed to have the time to think about what you're doing, not like fixing issues because you don't have a test that could have prevented it. And you know what? We've been talking about tests so far, but maybe you're thinking that tests are useless. And I would definitely respect that. I have coworkers who think that testing is not a good practice. I disagree with them, but I understand it. But if you think that tests are important, and I'm sure there are many people here who think testing is important, then you should care about making those tests good in the first place. Otherwise, the whole thing, testing, is just a waste of time. If you have tests in your code base right now that you think are useless, drop them. They're costing everyone money. They're costing time, like your time. They are a mental overhead for the people who contribute to the code base. They are taking CI time. So if you think that a test is not good, remove it, refactor it, but don't keep tests that are useless. So I would really much encourage you to try TDD, try it for a limited amount of time, measure the impact, and compare the results. And if you feel a bit intimidated by it and you're like, yeah, but I don't really know how to start, one thing that you can do actually is try it with bugs. Next time you have a bug, go with TDD and write the red step, and it's going to fail, obviously. And this way, you can fix your bug with TDD. So on a very small thing like that, you can try your hand at TDD, and the really bonus is that you will have a non-regression test, which is always nice. So definitely try it, and you may realize and be like, okay, Sarah, I tried TDD, and that's not really my jam. I respect it, but that's not really my thing. And that's cool. But if you try it, you may also realize that you just found a new technique that makes you really much more confident about hitting that deploy button. Thank you.